Hello friends, my name is Edgar Francis. Welcome to Internetworks. In this video, we are going to see routing protocol authentication of RIPv2, OSPF, EIGRP and BGP. Okay, if you want to know more in detail about the types of authentication and many more, please click the link in the description box. Okay, first we see the configuration of the RIP authentication. There's a fast Ethernet is connected. There's no space, so I have not write the IP address, but it's a 10 dot network, 20 dot network for all these routers. Okay, the IP address is already configured just to save your time. Okay, starting from the router 1, first we configure the RIP. So router RIP, and it's a version 2. Okay, and the network have the two networks, 10 dot network and 1 dot network. Okay, so 10.0.0 and network 1.0.0.0, not a summary and exit. Okay, same thing we are going to configure on this router 2 also. Okay, so router RIP and version is 2, network 1.0.0 and network 20.0, not a summary. Okay, let's see the routing table. Show IP route, you can see the 10 dot network R for router RIP, RIP. Okay, now on router 1, do show IP route, you can see 20 dot network in the router 1 routing table. Okay, now we are ready to configure the authentication. Okay, so first we need to configure the keychain and key string and the types of authentication, means the plain text or MD5. Okay, so first keychain name, you can use any. I'm using the simple one. Okay, and key is 1. Okay, now key string name is internetworks. Okay, now we have to apply this on the interface. The interface is serial /0 exit. Okay, interface serial /0 and RIP authentication, and here you choose the mode, MD5 or clear text. I'm using MD5, so MD5. Okay, now RIP authentication. Here we need to write down the keychain name. So keychain name is internetworks. Okay, exit. The same thing we are going to configure on router 2 also. Configure terminal and keychain name is internetworks and key is 1 and key string is internetworks. Okay, now we are going to apply this on the interface serial /0 and RIP authentication mode MD5 and RIP authentication keychain. The keychain name is internetworks. Okay, exit. Let's verify the routing table. Show IP route, you can see also, you can see still. Okay, now let's verify the chain. Show key chain, you will see the keychain name and key and all the other information. So that's how you can configure the authentication MD5 on the RIPv2. Okay, now let's see the configurations of OSPF authentication. Okay, so this is our router 3. In OSPF we also have just like an RIP, we also have the plain text and MD5 authentication. So now let's see the configurations of the OSPF authentication. Okay, when we have lots of interfaces, do not want to enable the OSPF authentication for each and every interface, we can also enable the area wide authentication by using the area authentication command. Okay, first we are going to configure the plain text authentication, and after that we are going to configure the area wise MD5 authentication. Okay, let's start. The IP addresses is already configured, so don't need to. Okay, so interface, and first we have to configure the OSPF. So router OSPF, let me show you. Okay, show IP protocol, sorry, do show IP protocol. You can see there's no protocol is running. Okay, so router OSPF 1 and network is 1.0.0.0 and 0.255.255.255. area is 0. Okay, and have the 10.network. Okay, exit. The same thing we are going to configure on router 4 also. Okay, so router OSPF 1 and network is 1.0.0.0 and 0.255.255.255. area is 0 and network 20. You can see over here the neighborship is up. Okay, do show IP route OSPF. Over here you see the 10.network is in routing table of router 4. Okay, now let's configure the authentication. First we are going to configure the interface level, after that we configure the global level. Okay, the interface is serial /0. Okay, so interface serial /0 and IP OSPF authentication. Okay, authentication, IP OSPF authentication. Again, now we have to configure the key. Key is internetworks. Okay, you can see the warning, OSPF warning, the password. Let's configure on the router 4. Okay, so interface and serial /0. You can see the neighborship is down. It will up when we configure the authentication. So IP OSPF and authentication, and again with the key is internetworks. Okay, the warning, soon the neighborship will up. Okay, you can see the neighborship is again up. Okay, show IP OSPF interface serial /0. You will see the password is the simple password. Authentication is enabled. Okay, now we configure the OSPF authentication in a global mode. Okay, configure terminal. Now the router OSPF 1 area 0 authentication. Okay, exit. Okay. When we have lots of interface and do not want to enable the OSPF authentication for each and every interface, we use this command. Okay. Now let's see on the router 4 configure terminal and the router OSPF 1 area 0 authentication. Okay. Exit. So this is how you can configure OSPF authentication. Okay. Now let's see the authentication of EIGRP. So EIGRP also supports of the different approach of the authentication route advertisement received from the neighboring router, plain text and hashing authentication using the MD5. Okay, so here also I already configured the IP address on this small lab. Okay, this is our router 5. Here we have to configure the EIGRP first. So router EIGRP 100, and we have the two networks again 1.0.0.0 and 10.0.0.0. Okay. Note a summary. Router 6. Okay. So router EIGRP 100 and network is 1.0.0.0 and network 20.0.0.0. Note summary. Okay, you can see the neighborship is up. Let's verify. Okay, show IP route. You will see over here D, the 10 dot network. Okay, D stand for EIGRP. Okay, now let's configure the keychain, and we are going to apply this on the interface. Okay, so starting from router 5, first we need to configure the keychain. So key chain and the name, again I am using the internetworks, and key number 1 and key string is internetworks. Okay, and exit. Okay, now we have to apply this on the interface. So interface is serial /0. Okay, IP authentication mode, there you can use EIGRP, and the AS number is 100 and MD5. So MD5. Okay, again IP authentication and a key chain EIGRP 100, and the key string is internetworks. So interworks, this is the key. Okay, it's similar to the RIPv2. Okay, exit. The same way we are going to configure on this router 6. You can see first the interface and then the IP authentication mode EIGRP AS number and MD5. After that IP authentication keychain EIGRP 100 and network. Okay, now let's go to the router 6. Okay, you can see the neighborship authentication failure. Okay, now first key chain and the key is 1 key string, his name is internetworks. Okay, and exit. Okay, now we apply this on the interface. So interface and serial /0 IP authentication mode EIGRP AS number and MD5. Again IP authentication session key chain and EIGRP, AS number 100 and name inter networks. Okay. Chain. Okay. Exit. You can see first the key chain, key number, key string name, then apply this on the interface. First interface serial /0, then IP authentication mode EIGRP 100 MD5, IP authentication keychain EIGRP 100 name internetworks. Okay. Okay. Now let's verify. First run the command clear IP route. Okay. Let's see, show IP route. You will see over here the 10 dot network is in router 6 routing table. Let's see, show IP EIGRP interface serial /0. You can see the peer and everything, all the information. Let me just write down show key chain inter networks. This is the name. You can see all the informations over here. Show EIGRP, show IP EIGRP neighbor. Okay, you can see over here the neighborship is up. Okay, so this is how you can configure the EIGRP authentication. Now the last thing is BGP authentication over here. Okay, so BGP authentication configuration is very simple. Okay, so BGP support authentication mechanism using the MD5 algorithm. When the authentication is enabled, any TCP segment belonging to the BGP exchange between the peers is verified and accepted only if the authentication is successful. Okay, so first we configure the BGP on router 7. So let me show you, do show IP protocol. Okay, now router BGP AS is 65011. Okay, so neighbor, the neighbor is 1.1.1.2 and the remote is AS is remote AS is an iBGP, so remote AS is also 65011. Okay, the network, two networks, one is 10.0.0.0 and network is 1.0.0.0 and no synchronization. Exit. Now we are going to configure on this router 8. Okay, so router BGP 65011 and neighbor is 1.1.1.1 and the remote AS is 65011 and the network is 20.0. and network is 1.0. No synchronization. Exit. Let's verify. You can see the neighborship is up, but show IP BGP. You can see the 20 dot network, 1 dot network. Let me see why there is not 10 dot network. Okay, let me see. The neighborship is completely up. Okay, okay. Do show IP BGP. Okay. Okay, so let me advertise this with the mask. Okay, and see. So router BGP 65011 and the network 20.0.0.0 and the mask is is a 7, no? So 10.0.0.0 and the mask is 255.0.0.0. network is 1.0. So okay, let's see on this router 8, router BGP 65011, network 20.0.0.0, mask is 255.0.0.0, again 1.0. Now let's see, do show IP BGP. It will take time. No, it's immediately get the routes in the routing table. You can see we are in router 7, this router, and we have the 20 dot network and the 1 dot network. Okay, the same way on this let's verify this router 8 also. So exit and do show IP BGP. You can see the 10 dot network. Okay, I stand for internal. Okay, now let's configure the BGP. Okay, with router 7 and okay, let's configure router and BGP 65011 and the neighbor is 1.1.1.2 and the password is internetworks. So internetworks. Let me capture here. Okay, 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 the internetworks. Okay, now we have to write down the version. So it's a version 4. So version 4, exit. The same way we are going to configure on this router 8. Okay, so router BGP 65011 and neighbor is 1.1.1.1 and okay, now we have to configure the version. So neighbor and 1.1.1.1 and version is 4. Okay, exit. Let's verify. Let's give this a time. It will come back. Okay, you can see over here the every packet every TCP segment is checked. Okay, as I told you earlier, when authentication is enabled, any TCP segment belonging to the BGP exchange between the peers is verified and accepted only if the authentication is successful. Okay, you can see. Now let's verify. You can see the TCP acknowledgement. Okay, retransmission. Okay, let's verify. Now let's see the routing table of the BGP. Show IP BGP neighbors. Okay, you can see over here. Okay, you can see the neighborship is down, and okay, let me see. Show IP BGP, clear IP BGP. Okay, let's wait. Okay, you can see the message come here. The neighborship is up after we clear the previous BGP routing table. Okay, now let's see. Show IP BGP. Before we don't have the 10 dot network over here. Let's see. Now we get the 10 dot network. Okay, so this is how you can configure the routing protocol authentication of the RIP, OSPF, EIGRP and BGP. The configurations is very simple. Okay, you just need to write down the neighbor and the neighbor address, password, name, and the version. That's all. Okay, I hope you like this video. If you like, please give a thumbs up, and thank you so much for watching this video. Thank you so much.